Hello there, folks. Hey, Joe Wazoo here. Hey, we're just going to build on a little program I wrote the other day with the snap signal. We're converting to a raw TCB string, and I learned from the application that really we just have one discrete signal that we have to read in on off, if you will, and from a relay that tells whether a red light is on or a green light is on. So what I'm doing in this application, team, is I'm using one of these really cool S15C-B22 modules or devices from Banner. They're called the Snap Signal devices. Really cute little boogers that have a lot of capability, a lot of fun. And so I'm using this one here, the S15C-B22-MQ, because I want to have Modbus out of it. And this thing will take in two discrete inputs and does all kinds of cool things with them. But in this case, we just want to take in the two discrete inputs. Now, what I'm using on this one, what's this page do? Oh, that shows there's a picture of it, but I'm actually using the pin 2 for the input on this thing instead of pin 4. So I'm using pin 2, and if I look at the Modbus mapping, that's going to be holding register 40,002 on RS45, pin 2 right here, okay? So if I go back to Crimson, here's my database, and if I go over here to communications, and let me just slide this down so you guys can see a little more. And in communications, you can see here I've got the RS45 Modbus master. I got the baud rate set to 19200. Data bits 8, 1, and none. That's default RS45 2-wire. Okay. And then when I add that driver, of course, you add the driver by hitting the pick button and you select Modbus Universal Master. That's how all that stuff shows up. And then right below there, then, normally this would say PLC1, but I always like naming things. So I actually call that device S15C underscore. They don't like any dashes here. So underscore B22 underscore MQ underscore number 1. So I put a number 1 here because that guy's going to be drop 1 default from the factory. It will be set up to slave address number 1. So I'm not changing the address here because I only need one of them. So that's what I'm doing for the communications to that thing. If I go over here to data tags, I want you to notice that I've got a flag tag right here. This is a flag tag. So if you hit the pull down, you can pick a flag tag here, or you can always right click on things, do new, and select that. A flag tag is a Boolean or discrete, just an on off. Anything that has whole numbers, you'll want to be an integer. And when you pick an integer, you can also change that to a floating point. But since this thing only has on off, I've chosen a flag tag. Notice that it's green, okay? Well, the reason it's green is because over here at the source, I went down and I picked that S15 device that we just talked about. And when I pick that, I select the holding registers, and I'm looking at the number 2 register. So here's a 4 plus this number. Let me go back to this sheet real quick. Will equal this holding register. So that's what I'm looking for right there, is that holding register. So when I click OK, normally this will come up as read and write by default because our driver doesn't know what this input is or whatever. So I'm going to make that read only. You don't have to, but I like to do that, plays it safe. So I got that read only. I'll save that change. Over here on display page, I'm just going to show that data here. And over here in programs, so I've got a little C program written here. And what the program is going to do, well, actually, let me go back. Let me go to communications, because the true goal of this is we need to feed that data over to some PC-based application as a raw ASCII string. So over here on protocol 1, I have chosen, by clicking on protocol 1, hit the pick button here. On the system, I have chosen raw TCP passive. So that's what I have there. And I've got a program here. It's going to, anytime it gets a message, it's going to execute this read message. And I'm using TCP port 1234. So if I go over here to programs, this is the program that's running. So if it gets a message, and the message it's going to get from the PC is going to send an R to request data, and then we're going to either respond with a G for the green light or an R for the red light that's on. So I'm going to read that string in, convert to my string, and then I'm going to ask the question, does it equal R? Because that's what the rules are for this application. If they send something else, I'm not going to read it because that was not part of the to-do list. Only if the unit sees an R will it respond. That's a request for data. So if the R comes in, then I quickly compare input pin 2. If it's on, I'll send back a G right here. And if it's off, notice this exclamation point here. That is the knotting. I knotted that. I don't know if that's a good word, but anyway, I knot that, meaning it's off. Then I send back an R. It can only be those two states. And this correct 1 and correct 2, I was just using that for testing early on to show on the display page. So that's the program that's running, or the application. Let's go ahead and fire this up, team. So here's that. Oh, by the way, I'm using PuTTY as my interface to this unit here. So on PuTTY, here's PuTTY here. If I put an A in, nothing happens, what have you. Okay, if I put a capital R in, let's see here. Not getting anything back here. And is this thing online? Let me download my change. Maybe I changed something here. All right, and okay, so that's right. Yep. So when I download that gets refreshed, I'm going to go ahead and clear this, reset my terminal, and then I'll do restart session. Okay, should be online with it. All right. So there we have it. Okay, so here we go. So A in, I'm just looking here. I don't know why this must not have been live, but anyway, if I put an R in, notice I get back an R right here. And on my input, I'm actually using the white wire, pin 2. And if I take the white wire and put it into V plus, you can see right here, this input went on. Now I have a green light. So if I do an R over here in the PuTTY window, R request, I get back a G. If I turn off my input, so if I take this out of the terminal here, there you go, it's off. If I put an R again, I get back an R. So it's working exactly the way it should. Perfect there. Now, one thing I'm telling you here, for testing, I'm using a G09 HMI. I like to use HMIs or something that has a web page so I can see what's going on. In reality, team, this application is so simple that I don't need the whole capability of a HMI. So let's see if we can convert this database to a DA10 possibly, and just use the DA10 thing to do this. So I've got the database saved. Everything looks good. I'm going to go here to File, Save Conversion. I'm going to click Data Station. I'm going to choose DA10. This is really the bare bones, most simple thing. And in this application, I'm just using communication data tags and honestly just a program. So let's go ahead and see if I can convert this. I'm going to do convert. All right, so here it comes up. I'm going to go ahead and call this one DA10. Oops, it's capital. What doesn't matter. DA10 here. I'll hit the save button. Okay, so it saved it. So in my opinion, it looks like you could use the DA10 to use this program, really, because all I'm doing is calling the program read message, which is here. Anytime I send an R, I do the comparison. The 485 port is here, so all the settings are fine. I don't see any errors, so I think you could get by with using a DA10 for this. I'm always an advocate, though, of using a DA30 or an HMI for testing. So I've tested this here. I'm pretty confident it would work, but keep that in mind going forward. Whenever I do a first project, I never, ever start with the DA10 because you get no diagnostics. There's no display page here. There's no interface. I mean, you can look at some, you can right click and do a, where is it here? Add to watch list, but I just don't like that. So, but the DA10 would work in this application, and that's it. Hey, thanks a lot, folks. Have a great day. See y'all later.